So you might say software as a service, SaaS. You might think of it as machine intelligence as a service, because it's not exactly software that you might use and expect of a GUI. It's really sort of a I don't know, intelligence in the cloud that you can provide it with data and it'll help you analyze it. And in that sense, it's, maybe it's a little bit different than software as a service. It's maybe intelligence as a service. 5 years from now, our dream would be to be essentially the ubiquitous middleware layer for all SaaS software. So one of the things that's happened because of software as a service, because of cloud, it's getting cheaper and easier to make new enterprise software. So I just saw a list of all of the available enterprise SaaS marketing software. There were over 700 applications, like 700 different marketing apps that you can buy if you're a company to help you do your marketing. So every company buys a different mix of SaaS apps, and every SaaS app stores its data in a different way in some kind of local data store. And it's just this exploding question of how are you going to get a single global view on what your company's selling, who's selling to, where its inventory is coming from, how much you're paying for it, all those things. So we see ourselves as essentially an autonomous machine intelligence layer that can just go into any one of those data sources, read it and understand it and pull it together for whatever view you need without any real human intervention. So just a set of pipes or kind of a utility that just flows information around the enterprise without a lot of effort. So we've just demonstrated some new scientific results, kind of on the laboratory side of what we do as a startup, where we showed that the more prior knowledge that you pour into a model, in other words, the richer the story that you tell the computer about the data, as long as it's the right story, as long as it actually describes the story of the data correctly, the richer, the more prior knowledge you pour into the system, the faster it learns, and the less labeled data that it needs in order to learn. And so we call that big model sometimes as opposed to big data. You don't necessarily need tons of data to train the system. In fact, we show that kind of a general principle is that as we put more and more prior knowledge in, we can reduce the amount of training that the system needs. We can essentially make it smarter.